We are putting a bit of work into solder this year. But I'm about to talk about solder itself, what the stuff is, and some of its little vagaries and things that we should know about it. Also, Neil has got a practical hands-on soldering session planned for just over a month from now. And I've also got a couple of other presentations like this. One on tools and techniques, where I will show you all the things that you can buy from China and how to waste your money. And another one on desoldering tools and techniques, where I will waste even more of your money. But those are yet to come. For today, we're talking about solder itself. If we understand solder completely, then soldering becomes much more agreeable thing to be doing when you understand what's actually going on. So let's start with what is solder. Solder is a eutectic alloy of two or more metals, usually tin and lead. Now, an alloy is two metals dissolved inside each other. The lead's dissolved in the tin, and the tin's dissolved in the lead at the same time. And eutectic is a technical word, and eutectic means that the melting point is the same as the drying point, is the same as the solidifying point. A lot of materials melt at one temperature and then solidify at another temperature. But if a material is eutectic, then the melting point is the drying point, is the setting point. An alloy is a material that's typically two metals dissolved in each other. And what happens there is you get material properties that are different from either of the two constituent materials. Now, in solder, the one that we're looking for is the melting point. Tin melts at 232, lead melts at 327, but you can get solders that melt from about 90 or 100 degrees all the way up to 700 degrees, depending on the composition. And this is why we use alloys. If you think about brass, it's 67% copper, 33% zinc, and it's an amazing material. It's used for all sorts. It's harder than copper, it's harder than zinc, it's more corrosion resistant, lasts forever, brilliant material. Bronze is 12.5% copper, and then a random mixture of aluminium, manganese, nickel, zinc, even non-metals. You get bronze with phosphor in it. But so is the phosphor bronze inside switches, the little twangy bits of contacts that you use. Those are bronze as well. Same material, slightly different alloys. Alloys are amazing stuff. I'm not even going to get started on steel. Steel's an alloy of iron and carbon, and we'll go there some other day. So here's typical solders. The standard one, 6337, or 6040 as it tends to get referred to, is the one that everybody talks about. It's the one that you use, and it's the one that most of what I'm talking about today will be about. But there are a whole range of solders, and that's why I've left those in up there so that you can see what we're talking about. And now, gentlemen, we delve into the dark arts. I'm going to save you the pleasures of Joshua Gibbs's free energy diagram because you don't need that. This is something called the alloy phase diagram for a binary alloy. This would scare the bejesus off you. And it's a very interesting diagram because nobody in the world ever sees it. If you're a civilian, if you're not doing this, then there's no need for you to ever know anything about this diagram. But if you're an engineer or you're a physical chemist and you're worried about metallurgy and stuff like that, because it tells us an awful lot about solder. First of all, the red spot there, I put a red circle round about the eutectic spot. That's the eutectic spot where solder goes from liquid to solid. And I'll explain that further as we go on down through these slides. Looking at the bottom, you'll see that the scale is from 0% tin, which means pure lead, over at the left, to 100% tin, which is pure tin, 0% lead, at the right-hand side. So 0 to 100% tin, you can read that in reverse as 100% lead to 0% lead. The magic point, where the red circle is at 60% tin, 40% lead. That's that eutectic point that I keep going on about. And up here, we have the temperature scale. I've marked all the interesting points. The melting point of lead is 327 degrees Celsius. The melting point of tin is 232 degrees Celsius. The melting point of solder is 183 degrees Celsius, but only if it's 60-40 solder. If it's some other solder, then you can see you got all sorts of places where it'll melt. But the lowest melting point is at 183. Now this line here is an interesting one. If you put sugar in your tea and stir it, the sugar dissolves. And if you put more sugar in your tea and stir it, the sugar dissolves. When you put the third or fourth or fifth sugar in your tea and stir it, you get to the stage where the tea can't take any more sugar, and you get sugar hanging about in the bottom of it. That's called a saturated solution. And that happens with alloys as well. And to the left of that yellow line there, the solder is saturated with lead, and you get lead crystals in the solder. Similar, in the same way over here, you can saturate the solder with tin. So there's a wee spliff there over to the right, where you've got solder with tin crystals floating in it, or appearing in it as solid. Tin saturates. The white area at the bottom is actual solder, solid solder. And it's only when it's below 183 that it's solid solder. So that line there is called the solidus line. Below that line, everything's solid. At some places above that line, where you've got the saturates at either side, you can have solids that are messy. But below that line, you've got solid solder. And if that's the solidus, then that's the liquidus line. And above that line, everything's guaranteed to be liquid. But it's not above the one temperature. The only temperature I can guarantee that you'll get a liquid above is 327 degrees. Below 327 degrees, you might have liquid with paste floating in it. You can get liquid solder that's got lead crystals in it, or even tin crystals in it. It depends on the temperature, and it depends on the phase that we're in. But because of that 327 liquidus line going up there, your soldering iron has to go to 320 degrees to guarantee to melt the solder. If you've got solder that has dried, you've got a dry joint and it's got crystals in it, a soldering iron that doesn't go up to 327 degrees may not melt that solder. It looks like it's melted, but you've still got a dry joint. So everything in that regime above the liquidus line is liquid solder, and that's the runny, silvery stuff. Those two areas I've already discussed. That's solid solder with solid crystals of either lead or tin in it. And those two areas are liquid solder with solid crystals in it. And that's heading towards a dry joint. I've made those areas on this diagram grey. And the reason that I made them grey was because if you're looking at a solder joint and it's grey and discoloured, then it means you're in one of those areas. You only ever want to live in the white areas where it's either liquid or it's solid solder. But if you see grey, then you're in one of those grey areas. You've got what's called a dry joint. Now there's a dry joint there, and you can see the rest of the joints on that board are shiny. They look like little volcanoes, smooth-sided. That one at the top is grey, it's not as shiny, and you can actually see the cracking occurring halfway down the slope of the little volcano. What usually causes a dry joint is one or two things, typically temperature shock. Now that occurs either because somebody blows in the joint, or a draft hits the joint, or whatever, but the joint gets cold. But also you can get it from mechanical shock. And the way I tend to think about mechanical shock is if you move a joint while it's cooling, then what happens is the joint, the solder comes in contact with either a bit of copper or a bit of component or a bit of soldering iron that isn't at the right temperature, and suddenly it gets cold suddenly. And if it gets cold, you get crystals forming. And if you get a crystal forming, then the remaining liquid is no longer the same composition as it was before. And because it's no longer the same composition, it's at another point in the phase diagram, and so another crystal will form. And now you've got two crystals and the stuff's out of phase, and you get more crystals forming. So it's a runaway thing, whereby once you start to get crystals forming, you're going to get a dry joint. But luckily, it's not a big problem. The only thing you have to do is put a hot iron in it, let it heat up to about 300 degrees, take the iron away and let it cool and anneal very, very gently, and you'll get no dry joints. And I'll show you how they do that in industry. The way they do that in industry is a thing called soaking or preheating. And in order to show you what soaking is, I'm going to put a line on here called the soak line. And the soak line is there to let me discuss Newton's law of cooling, which is how you deal with solder in an industrial situation. If I can keep the environment round about the solder at that soak temperature, then it becomes much, much easier to do the soldering. So although on the bench in the house, you'll not soak everything, you will do if you're using SMDs, and I'll talk about that when we're talking about soldering, but it's good to be aware of what the soak temperature is and what it means. Newton's law of cooling is a lovely wee law. It's been around since Isaac's time, 1701, and it says if you've got a cup of tea and you're sitting by the fire, then that tea will get colder much more slowly than if you take the same cup of tea out to the garage where it's Baltic. The colder the environment, the quicker something cools. Similarly, in the same way, if you've got an ice cream and it's hot outside, the ice cream will melt quicker than if you've got an ice cream and it's 2 degrees out, like today. An ice cream, you could walk for a mile with an ice cream today and it won't melt. Whereas in the middle of the summer, you go out with your ice cream, it melts almost immediately. So that there is the maths of it. And what I did was I put the maths onto a spreadsheet to give some examples that are close to the realistic, what happens with mass soldering iron anyway. So for standard 6040 electronic solder, I've imagined it starts at 17 degrees Celsius, which is room temperature. And if I take that piece of solder up to about 300 degrees, which is, remember I said, set your iron to 300 to make sure you melt properly, then it'll take about 5 seconds to get there. Time along the x-axis here, temperature along the y-axis. Now, the melting point, remember the eutectic point, is at 185. So that means that if I put my soldering iron in there, as the solder heats up, it'll melt at about 0.9 of a second, just under a second, which is right. If you imagine using a soldering iron and putting it onto a piece of solder, 1000 melted. That's about right. It takes about a second to melt, but it takes about 4 seconds to be up to the full temperature. If I'm using a pre-soak, if I'm soaking the thing, then it takes a tenth of a second to go from 175 to 185, which means that the soldering takes place almost immediately. And in an industrial setting, that's much better news. But it's even more so when I'm cooling. If I take it to run from 300 degrees down to 17, so I take my soldering iron away from the solder, that's what happens. If I take soldering the heat away and it's on preheat, then that's what happens. So again, if we put in the eutectic temperature, we can see that the time for the solder to set with a soldering iron is about a half a second, which is right. You take your soldering iron off a solder joint and you've got about a half a second before it sets. If I look at where it crosses the preheated line, it's there. I make that about 2.8, 2.9 seconds. Now that taking 3 seconds to set means that the solder is annealing very, very gently and I'm not going to get dry joints. Quick cooling is what causes dry joints, and dry joints are the most common problem that we debug in soldering. If you go to the Neil's soldering sessions, you will see dry joints. They happen, particularly if you've got a wee bit of board and it's moving, or you're trying to move it around about the bench, or you're breathing on it. In industry, you've got a setting time of 3 or 4 seconds in a machine that's preheated. You don't get dry joints because that way you don't need to rework the boards and you save an awful lot of money. So to that end, this is a typical industrial temperature profile. 4 phases. Preheat everything. The soak stage, where everything stays at the near the soldering temperature but not actually at the soldering temperature. And then it bounces up for a few seconds to the reflow phase. And then it takes a couple of minutes to cool down so that you don't get dry joints. Now that's a typical profile, but in reality, you have to worry about other things. If you've got connectors or sockets or stuff like that on your board that have plastic on them, that'll melt them. You'll end up with melted plugs, as I said earlier when I was talking about other things, and you don't want to melt the plastics on your board. Also, some components don't like high temperatures for too long. The favourite one here are MLCC capacitors, multi-layer ceramic chip capacitors, which is those little SMD chip capacitors. They don't like thermal stress. They tend to delaminate if you overheat them for too long. So you have to adjust your profile depending on the chip capacitors that you're using. And there's another thing, I haven't mentioned flux yet, but flux is a material that will be on your board and it activates at a certain temperature. So you'll have a line, a point on this profile where the flux is active, and you have to take that into consideration if you're doing this in industry. But we're not doing it in industry, we're doing it for us. There's an equivalent to the industrial oven, and it's a wonderful thing if you're doing SMDs, not so useful if you're just soldering through hole. However, we'll talk about that when we get to the presentation on soldering techniques, tools and techniques. Similarly, there's a hot plate for rework. If you're actually fixing, taking materials off boards, replacing components, replacing chips, then a hot plate like that is a really, really useful thing. And again, I'll talk about that when we're talking about desoldering tools and techniques. We're here today purely to talk about solder. So I've got 5 different types that I want to breeze through. We have plumber solder, builder solder, classic 60-40 solder, Electronic solder, which is the stuff we use, the lead-free and why it's there, and then there's a couple of specialist ones that we've talked about on here before, but I want to reiterate them because people aren't just as aware of them as they could be. Plumber solder or builder solder, or the solder that you get from Screwfix, is 60/40. It's used for the lead flashings on roofs. It's used for copper piping. It used to be used for lead piping, but there is no lead piping anymore, so we can forget about that one. And it's also used for the lead cams on leaded windows. I've got an insight here. My wife, for years, made leaded windows, and so I've spent a wee bit of time playing with leaded windows and doing the soldering on that. A stained glass window, as people popularly call them, or a leaded window, is made up of lots of little bits of glass, and they live in so-called lead cams that are like an eye shape, an I-beam shape, and the glass goes in either side of the I-beam. And then where these things meet in the corners, you cut it with a knife, a lead knife, and then you put solder, 60/40 solder on it. You tend not to see the solder because what they do after that is they rub over a lead phosphate wash over it, and that makes the whole lot go black. The solder goes black and the lead goes black, but there is solder in all those leaded windows. It's cheap, it's very easy to work with, it lasts forever. There's talk about windows being taken down that are medieval and the solder in them is still good. You need an external flux. The flux is used to clean the components and to aid heat flow. We'll talk about flux when we're talking about soldering. It comes in lumps and bars, it comes in cams, and it comes in strips. Now, electronic solder is used in old electronics. If you're repairing an old radio or an old television, it'll have 60/40 solder on the board as well. Modern electronics will have lead-free solder. It's still used for electronic repairs because it's much easier to use, much better characteristics than lead-free. In model railroading, we use it on printed circuit boards and Vero boards. If we're putting together anything from Merg, it'll be with standard 60/40 electronic solder. We use it in wiring, to solder wires to plugs, to solder wires to boards, to solder wires to wires. That's all 60/40. And we also use it in track droppers, which is the wires that run from the track to the traction unit, so that the power to run the model railroad gets from the power unit to the actual tracks. It's typically 60/40, although a lot of them nowadays have a little bit of copper in them to save bits. It used to be that because of the corrosive flux that you used, soldering iron bits were getting eaten. And you started with a soldering iron, and within a year, it was all gnarly and horrible because the flux and the solder were destroying the iron and the surface of the bit. Again, this is part of the discussion on soldering techniques. And you used to have to dress it with a file to clean it off. But nowadays, they've found that putting a little bit of copper into the solder stops that happening. It saves your bits. It is everywhere. There's all sorts of qualities of solder. If you want to buy solder from China, you is on your own. There's all sorts of horrible stuff comes in for China in the guise of being solder. I very often on here I recommend buying all sorts of interesting things from China. These wee modules that do that and this little tool that does that. I'm a great buyer of stuff from China. But if you're buying solder, please buy it from Radio Spares or CPC or a known standard local supplier that you've got come back with. And just before I go on to that, I want to tell you a wee story. I've already told some of you guys that story today, but it bears repeating. This is the classic solder that I used when I was a teenager, back in 19 oatmeal. 5-core Erson flux by a company called Multicore. The solder itself, they claim, has got 5 little cores up through it, each one full of this rosin flux. You can buy it on a reel, or you can buy it in a wee tube like that. If you buy the wee tube from Amazon, it costs you £10.58p plus a fiver for delivery. So you're £15 in. That is for 5 foot of solder, 1.22 meters. 5 foot of solder, £15. And when it arrives from Amazon, out of the box, out of the packet comes the solder, 5 foot of solder that you just paid £15 for, and a CPC delivery note. It's come from CPC in Preston. So if you go onto the CPC website and say, I'd like to buy the same thing, CPC will sell you it direct, £2.45 free delivery. So the choice is for that product there, £2.45 for CPC. And CPC are the cheapest. I mean, there's other people, Rapid or Arrow or whoever will sell you it cheaper. But CPC, £2.45, Amazon, £15. And it's no longer made in England, it's made in Malaysia these days. So, getting back to this, you get it on a wire, you can also get it as a paste. And the paste can either come in a syringe, in which case you squirt it out, and you can get things for making the syringe much easier to use. Again, we'll discuss that when we're talking about soldering tools. And I get a lovely thing from my friends in China for a couple of pounds that you will love and you will want. I promise. You say, I need those as soon as you see it. Or you can get it in a little pot like that. And what you do with the pot is you basically pick it out either with a spatula or a cocktail stick. And that's standard electronic solder. We've all used it, so I'm not going to spend too much time on it. Lead-free solder. Now, lead-free solder is nearly always nearly pure tin. It's tin with this and that and the next thing in it, and that and that and that in it, but it's nearly always nearly pure tin. In the 80s, the EU started bringing in the RoHS health and safety regulations, and that restricted the use of lead in products. And because lead was no longer allowed to be put into products, then lead solder was no longer allowed to be put into products. And so products started having lead-free solder in them, and a whole industry was born out of that. Now, this is the same discussion as we've had on the forums about selling people kits. If I sell you a kit, then I've sold you a printed circuit board and a couple of transistors and some resistors. And what you do, I've sold you my product, it's a kit. What you do with that kit is down to you. So for that reason, I don't have to comply with the regulations for when that thing is built. If that thing emits radio interference or attaches to the mains or any of that mains safety or emissions safety, none of that applies if I'm selling you a kit. And it's the same with solder. If it's a product, it has to have lead-free solder in it. But if I'm selling you solder, I can sell you leaded solder. And if you're doing repairs or you're making something up, you can use leaded solder. So whilst lead-free solder is now in all sorts of products, there's lots of exemptions. Interestingly, weapons, if you're building missiles, you don't have to use lead-free solder. So you don't have to worry about people's health when your missile hits them, that you don't give them lead poisoning. Medical equipment as well. But the exemptions also include repair and rework. They include making up prototypes. If you're doing a first version of something, then you don't have to use lead-free. But in reality, if you're doing a prototype for production, then at some point you will do a lead-free run just to check that your prototyping's good. And it includes hobbyist use. And I've taken two pictures there of two chips, one with lead-free solder and one with standard 6040 solder. And you can see the difference. You can see the shiny on the old-fashioned leaded solder, whereas the lead-free stuff is grey. The lead-free stuff mostly isn't eutectic. So when it's cooling, it goes from liquid to mush with crystals in it to solid. It doesn't go straight from liquid to solid. And that's why you get that discoloured look to the joints. You also end up with crystals swimming in the liquid, which means you get the opportunity for corrosion between crystals, which can cause lead-free to misbehave. And there's another thing that happens between crystals whereby if the thing is worked either mechanically or thermally, so you've got a piece of equipment, it gets hot, sunshine, it gets cold, dark, it gets hot, sunshine, it gets cold, dark. Then as these crystals flex a tiny submicroscopic amount, then whiskers of solder get exuded from the surface of it. And those whiskers can cause short circuits and can cause all sorts of damage. This is from 20 years ago, I think, when it became an issue that we'd been on lead-free solder for 10 years, and now they were starting to find power stations going offline, and Swatch had to recall 1 million watches because they were getting whiskers because the components were too close together, and when whiskers turned up, they could short things out. Now, there's lots of modern solders that are getting past the whisker problem, but it's still there and it's still a thing to be aware of. And as you can see, between whiskers and mush and colour and all that good stuff, for what we are doing, I do not recommend lead-free solder. It is there and it is available. There's 20 examples of it that you can get. Whether or not they're eutectic, they all melt at higher temperatures. You really don't want lead-free solder. Right? If you're in a manufacturing, if you've got to build something and you've got to make 1 million of them, you've got to think about lead-free solder. But if you're working in your layout, you don't. Buy a purn of 60/40 solder with flux in it from Radio Spares or Farnell or CPC, and you're off to the races. I want to talk very briefly before I finish about two other types of solder. I did a talk last year on vape batteries. These are the street lithium, they call it nowadays. If you're wandering along the pavements, you will find discarded vapes. And if you pull the vape apart, it's got a battery in it that's 3.7 volts and it's half an ampere hour, and it's a really, really useful battery. But one of the big problems with it is that the tags that stick out either end of it are aluminium and you can't solder to them. So that presentation is on the Merg website. Davey explained earlier we've got nearly 200 presentations on the Merg website. So I've put a QR code up there. And if you read that QR code, that'll take you straight to the vape presentation. And you can have a wee look. It'll not only take you straight to the vape bit, but it'll take you to the bit in the vape presentation where we're talking about this aluminium solder. It's a special solder that's made with tin, zinc, and a fluoride amine, some exotic inorganic compound. Incredibly expensive. We bought a purn of it and sold it off in, was it 2 metre lengths for £1 each? Because 2 meters is all you'll need in your life. What you do is you take your bit of copper and you touch the soldering iron to it and melt the tiniest amount of this solder onto it. It'll solder aluminium, it'll solder, you know those nickel strips that hold batteries together inside laptop batteries, or if you buy a battery that's made up of other batteries and they've got these nickel strips that hold them together, it'll solder those. If you've got an ordinary AA battery and you want to solder a wire to it, this will solder it. You know how you try to solder onto a battery and the solder balls and it won't stick? Give the battery a wee rub with some wire wool and a wee touch of this aluminium solder, and suddenly solder takes to it. It's magic stuff. And it's also very useful in track, particularly older track that doesn't have the modern nickel coating on it. And lastly, repairer's solder, sometimes called low melting point or quick chip quick solder. This is solder that contains bismuth or antimonum, and mostly it's bismuth. Forget anything else, just bismuth in this. And it's got a really low eutectic point, down to about 90 degrees. You can just about melt this stuff with your kettle. And what that means is that because the eutectic point is so low, if you take it up to 300 degrees with your soldering iron, when you take the soldering iron away, it takes 4 or 5 seconds before the solder sets. So if you've got a 16-pin chip on a board and you want it out of there, what you do is you go round about the pins and put a wee touch of chip quick on it, on each of the pins. And then you can run the soldering iron round about all the pins. And the first pin, when you leave it, you've got about 4 seconds to get round the rest. And when you get round the rest, they're all melted at the same time. And you can just pull the chip out. Whereas with normal solder, you melt the first pin, and by the time you go to the second pin, the first pin's dry again. It's hardened up. You put this stuff on, and you can desolder components very, very readily. Really, really groovy stuff. Expensive though. Now, you know how I'm feeling about Amazon today in terms of what they're charging and what they're charging for, but I went to Amazon to see. This kit, you can buy it from Rapid or Farnell for about £12. And if you buy the Rapid or Farnell one, you get 4 meters of the solder in a little tube. If you buy it from Amazon, you get 2.5 foot of the solder. And it costs you 16.5 quid. But 2.5 foot of this solder, I promise, will last you for years, because you only use half an inch of it on any one job, because you're just melting it. You've got a chip that you want off. You're only using, a centimetre to put a tin on every one of the pads of it. It's got its own flux, but that's just because they like to sell low melting point flux. It works with ordinary flux, and it works without flux. If you're just using your ordinary soldering iron, you don't need flux to use this stuff. But Chip Quick, they've got to make money as well, so they'll sell you the flux. And that little square thing is a wet wipe, only it's been wetted with IPA. You can buy IPA for £5 a bottle, so don't bother with that either. But it is very, very useful stuff, and I wouldn't be without it. We'll talk lastly about jeweller's solder. Jeweller's solder is the stuff you see them using in the repair shop. High melting point. If you go and look up a metallurgist's definition, hard solder or silver solder, jeweller's solder are all defined as being above 450 Celsius. It's used in jewellery. It's used for musical instruments, for putting tubas and trumpets and trombones together. It is very, very hard. It will bear loads. So it's used in certain industrial places where you have to solder things together. And it's used in sheet metal work. It's copper, zinc and silver. It needs a specialist flux because ordinary flux is melted in a way by the time you get to 200 degrees Celsius. This stuff, by the time you get to 450, the ordinary flux isn't there. So it needs a special flux. Usually you'll use a little propane torch to silver solder. And it has to pass assay requirements. By that I mean, if I'm working on a piece of jewellery and I'm putting solder into it, then there are rules that say if that piece of jewellery has to have a hallmark on it, it has to be a certain percent precious metal. And if I'm putting solder in which is not precious metal, then I'm lowering the percentage of precious metal in that piece of jewellery. So it might have to have its hallmark taken away, or it might have to have another hallmark put on it. So if you're working with silver solder, you sometimes have to be aware of assay issues. It doesn't matter for what we're doing, but I put it in simply to be complete. So how do we get solder? I started putting this together and I could think of 4 different ways that I've used solder. Bar, bar solder, wire solder, solder paste and solder tape. And I started looking them up and I couldn't find solder tape. It used to be that you could buy, it was a like 1/4 inch across flat tape, and you could tape it round about, like putting insulating tape on a wire. You put solder tape on the wire and then you just melted it and it fused. You don't seem to be able to get it anymore. I can't find it. So we're leaving that out. That's why it's been greyed out. There's bar solder. Comes in bars, long ingots. They weigh either 1/2 kilogram or 1 kilogram. You can buy it for China, you're on your own. You can buy it for reputable suppliers in the UK, in which case I would trust it. Solder wire. We've all seen solder wire. It comes in purns, spools, reels, whatever you want to call them, from about 1/4 kilogram up to about 1 kilogram. You get wire diameters from about 0.3 millimeters to about 10 millimeters. 0.3 millimeters, great for working with SMDs, but if you try to do something big with fine wire, then you're feeding yards of it in and it's silly. At the other end of the scale, if you get a big thick 12 gauge solder wire and you're trying to work with SMDs, there'll be blobs of solder everywhere. So you pick the gauge to suit the job. And I say I find them from 0.3 millimeters to 10 millimeters, which is 23 wire gauge to 000 wire gauge is 10 millimeters in diameter. Solder paste comes in 2 forms. That's what's called a Luer lock syringe. The front end has got a wee plastic thing that you can lock in and screw in and screw out, and you get different diameter needles. It's not a hypodermic needle, that it's a flat-ended needle for squidging the amount out. And as I say, there's some lovely wee tools for using these syringes to get just the right amount of flux or just the right amount of solder out. And I'll show you those when we're talking about soldering tools. The paste also comes in little pots, as I say. Very often the pot is the best way to proceed, because what you're going to do is you're going to take a little bit out with a spatula or a lollipop stick or a cocktail stick to use, because you don't use very much of this stuff at the one time. It recommends that you refrigerate it. What it actually is, the paste, is tiny little balls of solder, like 5 micron, 7 micron balls of solder in flux. And they say, put it in the fridge to stop it from drying out. I have found that if I just leave it lying about the bench, it dries out. And when it dries out, what I do is I put a little squirt of flux in it and mix it about with a lollipop stick, and it comes back into what it was before. And so refrigeration is technically necessary. They'll probably not guarantee your work if you haven't refrigerated it. But I've got stuff there that's 10 years old, and I still just put a little squirt of flux in it and give it use a lollipop stick to mix it back up into a soft paste and then use it. We need to talk about flux. Flux is a chemical that is used to clean the material that's being soldered and to assist heat transfer. You can get it in liquid, you can get it in jelly, you can get it in a solid. It looks like a sort of, it's solid the same way that boot polish is solid. It's a sort of thick waxy thing that you can rub. Or you get gas fluxes for industrial uses. We won't be talking about those. In fact, we won't be talking about fluxes at all here. We'll talk about them when we talk about the actual art and science of soldering, which is the next presentation. And again, how to apply it. There's a blowtorch, there's a heavy iron, there's an electric soldering iron. Wave soldering, we'll not concern ourselves with wave soldering here, but I've got a marvellous story about it. Pot soldering, you can buy a little pot that lives in your bench and lets you just dip wires into it. But it's an expensive way of using solder, and I'll talk about that when we're talking about soldering. There's three different types of reflow: hot air, contact, and infrared. And again, the next presentation is on how to solder, or the mechanics of solder, the tools and the techniques. If it's actually how to solder, then Neil's going to go over that in his practical session next month. Meanwhile, I've done plenty. So it's that stage where we either get a stunned silence or we get questions or comments. Over to you, folks.